use substitution to integrate the integral of tangent x dx. Now, it might not be clear where we should even start because we don't see this as a composition of functions. But what we can do is we can rewrite this integral, the integral of tangent x dx, as the integral of sine of x over cosine of x dx. We know that that is how tangent is actually defined. It's the ratio of sine of x and cosine of x. And we still don't have a composition of functions anywhere, but there is something really interesting here. If you look at the denominator, cosine of x, and we make that our substitution, let's let u be cosine of x. The derivative of cosine is negative sine, so this is going to be negative sine of x. And when we move that dx over, we've got du equals negative sine x dx. And an interesting thing happens. If we replace cosine of x with u, the leftover bit is sine x dx, which is going to end up being negative u. If we divide both sides by -1, that's going to give us negative du equals sine x dx. And this particular substitution happens to work out in a way that allows us to replace everything with x's here and write them in terms of u. So let's give a try here. I want to do one thing first that might just make this look a little easier to some of you. I'm going to take this sine of x and I'm going to actually move it outside of the fraction. So I'm going to write this as 1 over cosine x, and then after that it'll be times sine x dx. Doing that makes it a little easier for some students to follow along, because once we make our substitution, 1 over cosine of x is going to become 1 over u, because cosine of x was equal to u. And then sine x dx is going to be negative du. I'm going to put the negative out front. You can think of that as the same as negative 1 du. So we're pulling that negative 1 out front. So we've got 1 over u inside our integrand, but we know what the indefinite integral of that is, or the antiderivative. The antiderivative of 1 over u is ln of the absolute value of u. And we also have the negative there, and we still need our constant of integration, so that's going to be plus c. And then we can't have our answer in terms of u. We have to substitute back in for the x. So this is going to give us the negative logarithm of the absolute value of cosine of x plus a constant. And this is the result when we integrate tangent of x dx. Earlier, we were given the integrals of sine and cosine, or we figured those out together, and then those became integrals that you just memorized, so you could always integrate sine and cosine pretty easily. And now we have a formula for the integral of tangent of x dx. If you ever come across that and you remember this, you don't have to go through that whole substitution. You can just say, oh, I know the integral of tangent of x dx. It is negative ln of the absolute value of cosine of x plus a constant. It might seem right now a little bit ridiculous for you to memorize that, but here's the thing. I've mentioned that integration ends up being a lot more complicated than differentiation. There's a lot of rules and methods and things like that. And I'm going to be honest, the more of these basic integrals you have memorized, the easier it will be moving forward when you encounter them to just remember the result and use it instead of having to go through and break tangent up into sine over cosine and then make a substitution and differentiate and plug it in and all that yada, yada, yada. The more of these you can remember, the easier things will be moving forward. So just try your best.